Good afternoon to all. I am Professor Ashok Vidhate. Today, we are going to conduct a next lecture on the subject control system. Or in the control systems, in the previous lectures, we have studied about the introduction to the control system, the elements of the control system, then the definition of the system as well as the definition of the control system. Then also the next point we have also studied the classification of the control system, and in that classification we have studied the first point is nothing but the closed loop control system. So in that closed loop control systems, or not as closed, in the first, that is nothing but the open loop control system. So in that open loop control system we have studied about the definition of the open loop control systems with the examples of that open loop control system. So in the next lecture we will study, or in this lecture we will study the closed loop control system. So how we are able to define the control system as a closed loop control systems, or we know that here the formation of the loop is happening into that control system. So if there is a loop we know that from starting point, then merging, or here we are going to the another point, then repeating, come to the same point at the time, here is a formation of the loop. So the closed loop control system is defined as a system in which, here, the controlling action, or we are calling that, in that system or in that control loop system, the controlling action or that input is dependent on the output, because here the output values we are applying as an input to that system. So if we see the diagram of these closed loop control systems, or here there is a formation of the closed path. So if we see here, from this point, from that is nothing but the that circle path, then here we are forwarding, or here to the output side, then back to the input side, or here there is the input side, or that circle with cross we are calling is known as a summation part, or that is the representing a summation part. So here is a formation of the closed path, or here generally if we say the controller action is dependent on the input, but that input is from the command input as well as from the feedback path, or here we are taking the output side directly as a feedback towards the input side. So here the output of that system is depending on the two parameters. The first parameter is nothing but the input. On that input, that output is dependent, and another one is nothing but the feedback, or that is we are calling as the feedback signal. On that feedback signal, that part is depend. But here there is a formation of the loop, or if we start from this point, here we are forwarding, after that in the back side we are coming to the same point. So there is a formation of the loop. So if there is formation of the loop, at that time the system we are calling as a closed loop control system. And in that closed loop control system, here the main parameter which is available into that closed loop control system is nothing but the feedback. Or feedback is nothing but we are providing the output of that system to the input side. We are providing the output of that system to the input side, and that providing that output to the input, we are calling this one as a feedback. So in sometimes that feedback will be of the 100%, that feedback will be of the 10%, or in between any value from 0% to the 100%. So if that feedback is 0% or there is a no any kind of the feedback. So here into that feedback control system, or we are also calling that closed loop control system as a feedback control system. The closed loop control system is also called as a feedback control system. So that closed loop control system is also called as the feedback control system. And here we are using the feedback element. The main purpose of using that feedback element is to apply the output signal to the input side. So when we are applying that output signal to the input side, when there is a feedback element, or by using that feedback element, we are providing the output to the input. And also we are able to say that that feedback is a property of a system. Or how can we define the feedback? Feedback is a property of a system by which the output is applied to the input side. And when we are applying that output to the input side, here the first part is nothing but the error detector. The main function of that error detector is to detect the value, or here generally if we are considering the example with respect to our air conditioning system. So air conditioning system, in that air conditioning system, what happens in our room, there is a larger temperature or hot temperature is available. So to reduce that hot temperature to our compensable value, or to a to with our desired value, or generally if we want our room temperature must be of the 10 degree centigrade, or if the temperature we want is of the 10 degree centigrade. So how we are able to find out that 10 degree centigrade temperature? Or firstly we are fixing the value at the reference side, or we know that in our air conditioning system we are having a remote. In that remote we are placing that command input, or we are placing the value as a 10 degree centigrade, or we want the temperature which is of the 10 degree centigrade. So here if we fixed value, but right now the temperature at our home is nothing but the 40 degree centigrade. So if that temperature is of the 40 degree centigrade, at the time the feedback is provided from that output side towards the input side, and that feedback value is nothing but the 40. So here what happens, that error detector, or here that is nothing but the summation amplifier, or we are calling this one also as a summer. SUMMER. Summer means we are adding the values of the output with respect to the input. Or here, but that is the feedback, and generally in our system the feedback which we are using is nothing but the negative feedback. So if that value is negative feedback, here the temperature, or here that error detector gives us output as here 40, that is actual value minus the our required value, and that temperature is nothing but equal to the 30 degree. Or here the temperature which is in our system is our 30 degree than the desired value, or desired value is 10 degree centigrade. So here what happens, if there is a error or of the 30 degree, means here that error detector gives a signal, or that is nothing but signal is nothing but the E of the T, that is the error signal which is provided to the controller. Or here the controller is nothing but it can direct the process, or it can direct the system, or it gives directions to the system. So in our AC, all here air conditioning system, the controller is in the on condition, and it says to that temperature cooling system or that AC, that AC must be in the on condition. So here to decrease out the temperature. So after that, if the temperature is reaches towards the 30 degrees, at that time there is also a difference, that is the 30 minus 10, that is nothing but the 20. Then after it reaches to the 20, there is also difference. So here that air conditioning system is also in the on condition. But after that, what happens if that temperature is reached to the 10 degrees centigrade? Here 10 minus 10, or here 10 minus 10 is nothing but equal to 0. So it says that if there the input value or desired value is 10 and output value is also 10, so here there is subtraction, 10 minus 10 we are calling as a 0 degree centigrade. So here the difference between the desired value and the output value is 0. If that difference is 0, means here we have reached at the temperature of the 10 degree centigrade, the 10 degree centigrade, which is our required temperature. So here we are calling this one output as a controlled output, because we are controlling the value of the output. We want 10 degrees at the temperature at the output side of that air conditioner. So here that value is reached, so we are calling this one as a controlled. So generally we are calling as a uh, calling this one as a general output, but here instead of that general output we are calling as a controlled output. And here we are also calling as the reference input, or here the reference input we are placing that value. Then here the reference input and that signal is with respect to time, because here that all the values are with respect to time, because the feedback is provided time to time, or here we are running that system with respect to time. So here all the signals which we have defined into that system is nothing but the with respect to time. So here the reference input, the equation, or here general we are symbolically representing as a r of the t, or that one we are representing as a r of t. Then here the r of t is compared, or here that error detector, or here it is compared means here added or subtracted with our feedback signal, or that feedback signal we are calling as a b of the t. And r of t plus or minus, here the sign is given. If there is plus sign, then here input, reference input plus feedback signal, that is the added. If there is negative sign, then here subtracted. So based on these values, or here if that positive sign is given, we are calling this one as a positive feedback, and if there is a negative sign given, we are calling this one as a negative feedback system. So here after that, the E of the t, or we are able to write down the E of the t equation as E of the t, E of the t is equal to R of the t, then here plus minus that sign we requires, or we are calling this one if there is the positive input, or generally the negative feedback is there. So r of the t is equal E of the t is equal to r of the t minus b of the t, that is the feedback. That is the equation for that error signal. Then here after that error signal is applied to the controller, and the output of that controller is nothing but the m of the t. So here E is nothing but the error signal, then R is nothing but the reference signal. Then how can that m of t, or m of t is nothing but the manipulated signal, or that is the output of the controller, because here that is the manipulated value. So that is nothing but the m of the t. And here after that manipulated signal we are applying to the process or to the system. And when we are applying to the system, at that time it gives the output as a controlled output, and we are representing that output as a C of the t. And here the B of the t, that is nothing but the feedback. So we are providing that output to the input side, so that system we are calling as a feedback system. And always remember that if there is a positive feedback at that time, this system is called as the positive feedback system, or if that sign is plus, and if that sign is minus, then we are calling this one as the negative feedback system. So these are all the things about that closed loop control system. So here forward path, we are having the two path, forward path, and here feedback path. The next one, advantages of this closed loop system. So which are the advantages of the closed loop system as compared to the open loop system? So here advantage is that the accuracy of that system is very high, because here we are putting that value in the output side. We have put the 10 degree centigrade, that is continuously checked, or that is continuously checked by the feedback element. So if we are checking the output at a time, here we are obtaining the value, and if that value is we are obtaining at a time, that value we are providing as the input side. So here we will check if that much signal is given, then what is happens in the output side, and based on that feedback the controller selects the correct value that should be applied to that process or to that system. So due to that, here the accuracy of that system is very larger. Then another one is nothing but the what happens in sometimes there are the environmental disturbances. So environmental disturbances are nothing but the temperature, humidity, as well as the waters, or due to that what happens, our system can be gets changed. So if the system can be gets changed due to the temperature, but here if that system output is changing at the time, it is we are continuously applying toward the feedback side. So if there are changes due to the temperature, or we know that room temperature at the winter season is about 20 degree centigrade, and the room temperature at the summer is about the 40 degree centigrade. So here there is a temperature difference or environmental disturbances that can also affecting our system. But here due to the use of that closed loop system, the environmental effects can be minimized, or here that system senses that environmental effects and that can be removed out. Then the third advantage is nothing but the bandwidth and system, or bandwidth of that system is very larger. Or how we are able to define the bandwidth, or we know that the bandwidth is nothing but the operating range of that frequency. So if some circuits are operating from 10 hertz toward the 200 hertz, that is the operating range of the frequency. So number of electronic devices are operating on the frequency. So based on that frequency, the bandwidth of a such system is very larger, or here it is having very large operating bandwidth. So here at small frequency that system can also be we are able to use, as well as at the higher frequency we are also able to use that system. Then here the another advantage is nothing but in that system there is a effect or reduced effect of the distortions. So if there are or here output side distortions can be generated, or artificial distortions can be occurred within that system, that can also be reduced, because we are continuously checking the output and that feedback is applied toward the input side. So if there are any kind of the changes can be done at the time, that can be applied as an input, so that can be overcome. So here non-linearities and distortions are also be avoided. So we are also able to say that the system is highly accurate. Then unit now the another one point is nothing but the disadvantages. So if these are having such advantages, then every system has some disadvantages, or that here the first disadvantage is that from the design point of view, or if you want to design a system, at that time the closed loop control system, the design is complex. And if that design is complex, it is nothing but the costlier system, or here cost of that system is very large. So if we see, that is the heater, or generally we know that during that winter we are using the heater to heat the water. So generally what the heater we are using is of having a simple, this is nothing but the open loop system, or here we are putting that, immersing that heater into the water, and that heater is in on condition as per our time, or we keep as a 30 minutes, 40 minutes, or here some keep at a 20 minutes also. So based on that, but here that heater does not understands that water is heated or not. So if we forgot to switch off that heater, what happens, that can heater burns our buckets also. So this one is the disadvantage of that open loop system. But here it is very simple to design a heater. But if we consider a geyser, that is geyser, it senses the temperature reached, if we are considering the temperature is of the 40 degree centigrade, that geyser senses that temperature of the 40 degree centigrade is reached, and it becomes in the off condition. So if we keep that geyser on for a longer time, but here that geyser is having a feedback, so it checks its output. Or we know that the electronic press, to press our clothes we are using a press, but right now that press is having the controller values, or here for the cotton, for the here silk, for that purpose various temperature ranges we have fixed. After reaching that particular temperature range, at the time here that electric iron which we are using are becoming in the op condition. That is the right now example, or today's example. But in the previous one, what happens, that electric press which we are using in the previous times does not have any kind of the controlling options. So if that we keep that electronic press on for a longer time, at the time it remains on for the longer time, and it possibility to burn our clothes. So for that purpose we are providing the controller the similar way, because here the senses its output, and based on that output value it is in the off or it is in the on condition. So but here from the sensing, or here from the design point of view, the closed loop control system is very complex, and yes, the complexity is having, it is also having a cost. So if we consider in the markets, the geyser and heater, these are the different, but the cost is also different. The heater is having less cost, but geyser is having more cost. Then second one, due to feedback, or what happens, we are providing the feedback to that system. So the effect of that feedback is such a way that if there is a possibility of the positive feedback, if we are providing the positive feedback to that system, then here what happens, the our system can be work as an oscillator. Or we know that if that positive feedback is applied, it work, or it will work as an oscillator. So here it gives oscillations within the system, and if they are in our system there are the oscillations, then what happens, due to that oscillations there is a possibility of the damaging of our system. So during the design point of view, it is also seems that the system does not create more oscillations. So if that oscillations are very larger, then system is we are calling as a unstable system. So we are designing the system in a such a way that the system must be in a stable form. Due to that stable form design, here it avoids the damaging of the system. So if we compare, the next point we want to study is nothing but the difference or your comparison in between open loop control system and the closed loop control system. Sometimes here control system word is not written. Sometimes here the control system word is not written. So here we are also able to say the system as open loop system as well as the closed loop system. So open loop system, how we are able to define the open loop system? Or in that open loop system there is a no feedback path, or generally into that open loop system how we are able to design, or that system is only having one input or it is having one input and one output. So there is no any kind of the feedback path. So we are calling this system as a open loop system. Then the next one is nothing but the closed loop system, or in that open loop system there is no any feedback. So here if there is any changes in the output has no effect on the input, because we are not checking its output value as in the feedback form. But into that closed loop system what we are doing, we are checking the output of the system. So how we are able to check the output of the system? So here firstly the system will be like that, or we will draw, or we will some better way. So here output, then here input and output, but here we are providing that output to the input side, or that output, so we are providing that output towards the input side. So here we are checking the output value, and based on that two or combining of that two we are applying to that control system. So here the any changes in the output affects the input, and if here there is a changes in the output area where feedback is provided backside, so here their changes in the output affects the input which is possible by the use of feedback. So we are calling this one as a closed loop system. Then in that open loop system output measurement is not required. So into that open loop system, the output measurement is not required for the operation, because here to operate that system we are not able to check the output value. But here in the closed loop control systems we require to check the output value. The output value we are checking. So after that output value we are checking, we are applying that value as a input side. So that values we are required. The next one, third one is the feedback element is absent in the open loop system, but in the closed loop system the feedback element is present, because here that is nothing but the feedback, and to provide that feedback we are using one feedback element. Then here into that closed loop system, or here in the open loop system error detector is absent, but error detector is necessary in the closed loop system, because here we are here providing a summation or summer. Here what we are doing, here we are adding that input desired value with respect to the output value, and finding out whether that two values are different or not. If there is a difference we are calling this one as a error signal, and that error signal we are applying to the controller. So here error detector is necessary in the closed loop system. Then here the open loop system, the next one is nothing but it is inaccurate and unreliable. So here that open loop systems are inaccurate, because here the feedback is not checking, or it is remains on, or if we make the switch on that heater at the time it remains on, it doesn't tells about that how much the temperature has been reached, or it is reached to our 20 degrees centigrade or 40 degrees centigrade. We have to check, or the temperature we have to check of that water by inserting our hand. So here, due to that, it is inaccurate and unreliable. But here, if we use the geyser, water geyser, or here we have fixed the temperature value, then heat reaches to that particular temperature and it becomes off. So we are calling that closed loop control systems are highly accurate and reliable. Then the another point view is highly sensitive to the disturbances, because here that system, if there is temperature changes or changes has been occurred at a time, we are keeping that system dependent on the temperature. So here the output of that system is changed with respect to the environment. But here into that closed loop system, we are sensing the output and continuously applying a feedback. So here less sensitive to the environmental changes. The next one, the bandwidth operation or the frequency range or frequency operating range of that open loop system is small, whereas the bandwidth or here frequency operating range of that closed loop system is larger. Then next one is nothing but the generally these open loop systems are stable in nature. But if we are considering the drawback of that closed loop system, this system is having the major drawback is that the stability, or the stability is major consideration while designing, because here we are designing that system in such a way that that system must occur into the stable operating region. So here the next one is nothing but the highly effect of non-linearities. If there is non-linearities, then that can highly affect to our system. But here reduce the effect of the non-linearities in our closed loop system. So these are the differences in between that closed loop system. Always remembers that uh, the closed loop system is very better, or it is having the much advantages as compared to the open loop system. So in the next point we want to study is nothing but the examples or examples of the closed loop system. So which are the examples of the closed loop systems? So first example of that closed loop system we will see is nothing but the human being driving a car, or when the human is driving a car on a road, and if there is any turning point on that road, or at that time what happens, here our hand or the we are driving, or if considering one person is driving at that time, his hands are on that steering of that car, and the hands are moved as per the path of that road. If there is turn on that road, at the time that hands are moving. If the turn is right hand side, hand are also moving toward the right hand side. So in that example, so here the reference input is nothing but the position, or if we consider there is a turn which is available on that road, then here our eyes or the feedback, or here we want to desired position of the hands based on that feedback. So here our eyes are working as a feedback. So when we are going to turn or taking a turn on the road, at the time here our eyes are looking whether our car is going downside of that road or not, or it is at a correct position that can be given, or here our eyes are providing feedback to our brain. And here the difference, or if we are going to turn at the time, if there is a changes, if we are rotating that steering, but here not more rotation of our wheel or of our car has been done at a time, there is a difference. or here eye is giving the signal to the brain, and brain on the based on the input value to that brain, the brain gives a manipulated signal, and that main brain is giving the manipulated signal to the hand, and due to that here the hands turns as per the signals given by the brain. So here always remembers that in our human body, the brain is nothing but the controller, and hands, or in that human driving a car, hands are nothing but the process. The driving process can be controlled by using a brain, but here the feedback is provided by using the eyes, and eyes are continuously providing to the or continuously providing the feedback to our brain. So we are calling this one as a closed loop system, because here there is closed path formation. But what happens if we consider that system as an open loop system, or there is absence of the eye? What happens if there is absence of the eye? The brain does not understand whether that car is on the road or beyond the road or going to downside the road, if their feedback is absent. So here the feedback is very necessary. So if that feedback is absent, what happens? If that is absent, then our system is inaccurate. So here to work that system in the accurate form, the feedback must be present. So this one is about the points regarding to the open loop control system and the closed loop control system. So if anyone is having any doubts regarding that open loop control system and the closed loop control system.
No, sir.
Okay. So I have also shared the books regarding that control system on our WhatsApp group also. So you can also read the books as I am teaching. So we will stop here and conduct the next examples, or here another examples into the next class. So that is nothing but the liquid level control system. We will study in the next lecture. So we will stop here. Thank you for the joining. Any doubts?
No, sir.
Okay, thank you. We will end the meeting.